Derivative fractional indices. Again, we have this rule. The function x equals x to the n, then the gradient function f dash x equals n x to the n minus 1. And this will also apply to fractional indices. But first of all, we have to change that square root function to a fraction. So that becomes fx equals x to the power of half. So the gradient function then will be equal to half comes down, x to that, and take 1 away, that's going to be minus a half. And you could rearrange that and write that as 1 over 2, and that will be square root of x, because that becomes a positive as we go down. This one here a little bit longer. So before we actually play with this, we've got to change that to an index form. So that becomes x squared times x to the half. And so fx equals x to the, and we'll write this not as 2.5, but 5 over 2. So f dash x is equal to the 5 over 2 comes down, and we take 1 away from that, becomes x to the 3 over 2. You could leave it like that, that's absolutely fine, or you could put it back in the square root form, and that becomes x root x. So that's x to the 1, x to the half, 1 plus a half is 3 over 2. Now in application, we move across to this one. The tangent to y equals the square root of x is perpendicular to the line x minus 2y plus 1 equals 0. Find the point of contact. Okay, so we're going to work out the tangent by differentiating this. So we have y equals x to the half. We know what that is, we've just done that over here. So f dash x is equal to 1 over 2 root x. Okay, so we know that this is parallel to this line, so we're going to rearrange this to work out what the gradient is. So now we've got x plus 1 equals 2y, so y is equal to 1/2 of x plus a half. So therefore, we can say that 1 over 2 root x is equal to the gradient here, which is a half, and that becomes root x equals 1, or that x is just equal to 1. So when x equals 1, we would work out what the y value is by putting that back into the function here, and the y value obviously also is 1. So now to work out the point of contact, well, it's just going to be 1, 1. Done.